So today we are going to study the derivative using the chain rule. Okay. What is the chain rule? A chain rule. Chain rule. It means I have something covering something else, right? This is a chain rule. Okay. So it means I have u as a function of x and x as a function of t. Okay. So I'll make this one in red just to be very impressive. U as a function of x, and inside this one you have x as a function of t. And you would like to have what? Du not by dx, du by dt. So the big one is u, you differentiate it with the smaller one dx, and the smaller one is already is a function of another derivative t, so multiplied by dx by dt. Some people saying if you cancel this one is equal to this one. This is mathematically wrong because you cannot cancel out, because this is one piece is a slope and this is a slope also. This is a chain rule. How I can use a chain rule? Let's have an example. Find d by dx for x squared plus 2 to the power 4. So what is the big one? The big one is the power 4. What inside this big one? I have x squared plus 2. So my u is this one. This is my u. Okay. And x, what is inside this one, right? Okay. So I'm going to do what? How to solve this one using chain rule. You have d by dx for x squared plus 2 to the power 4 as one piece, and you multiply it by d by dx for the smaller one, x squared plus 2. So I know when I have a power, okay, I get the power down and subtracting 1 from the power, so I am subtracting 1 from this. It will be 3. What is the derivative of x squared? 2x. What is the derivative of 2? Is 0 because it is constant. So I end up with what? Yes, I end up with 2 times 4 is 8. X times x squared plus 2 to the power 3. This is how to use a chain rule. Okay. Also, sometimes you use this one if you have, say, find d u by dt f u equal to x squared plus 2x plus 1 and x equal to cosine t. So what I'm going to do with this one, I'm going to use the chain rule. What is the chain rule? I'm looking for du by dt. I cannot differentiate u straightforward with respect to 2, but I can differentiate u with respect to x. That's fine. And then I can differentiate x with respect to t. Yes, it will be the same as du by dt. Let's do it. Du by dx. So it is d by dx for x squared plus 2x plus 1. This is u. Times dx by dt, d by dt for x. What's x? X is cosine t. Okay. Now, What is the derivative of x squared? 2x. What is the derivative of 2x? Is 2. What is the derivative of 1? 0. No need to write it down. Okay. What is the derivative of cosine t? Minus sine t. Be very careful with the minus, so you had put the bracket. Okay. Now you can write the minus in the front, sine t, or it is better to write x plus 2 first. Sorry, 2x plus 2, and then you write your sine t. This is how to use the chain rule. Okay. Today we are going to use our chain rule to know what is the derivative of the logarithm and exponential function. Okay. Let's go and see this presentation. We know the exponential function is increasing all the time if a is positive, right? So it's increasing. And of course, a is not equal to 1. Just to be defined value. This is a function y equal to the a is the x. Exponential function is always increasing, right? Okay, but when it goes to minus infinity, it will be 0. So it has horizontal asymptote. Do you remember the horizontal asymptotes? Yes. But it doesn't have a vertical asymptote because it is not rational. And also it has no 0 for the denominator, right? Okay, because it is not rational. But it has horizontal asymptote because when x tends to minus infinity, my function goes to 0. Okay. What is the inverse of this function? I know if I have x go up cross this curve y equal to x and go here, I find the value of a to z, this value x. So the logarithm function is the inverse of the exponential function. I know this. So instead of going from x to a to the x, I coming from y to the inverse. So it will be the logarithm of y with respect with the base a. Okay. Yes, this is the logarithm for a base a. So the inverse function of the logarithm is the exponential function. The inverse function for the logarithm is the exponential function. Okay. So look at this one. Because it is the inverse, so it is exactly like you reflect this one in the positive side because no logarithm has a negative, no logarithm for negative values. So if you look at x, you will never find x in the second quadrant or in the fourth quadrant. You will find only x in the first and the fourth quadrant. So x positive only. So no logarithm for negative values. But the logarithm itself could be negative value. The logarithm itself could, but there is no logarithm for negative value. Okay. How to find the derivative using the definition? We know how to use the definition. We add x instead of x, x plus h, and f minus f of x over h when h tends to infinity. This is the limit, but we end up with a problem with the limit of 1 plus k over to 1 over k when k tends to 0. We don't have L'Hopital rule now, but we can understand the limit using a table, right? So I have the value of k. I calculate 1 plus k to the 1 over k. Okay, and for k positive and k negative, very close to 0, right? So this value 1 plus k over 1 over k, when k tends to 0, is almost around 2.71. And I remember, what does it mean, 271? This is what this is Napier's constant, right? So this is the E, the value 2.71829 something is the approximate value for this Napier's constant, which is E. So I end up with the derivative of logarithm is 1 over x times the logarithm of a over 1 over x times the logarithm of a with this. What about if a itself is e? If a is e, so I will end up with d by dx, and logarithm for the base e, we write it len, right? And the derivative will be 1 over x. Can we solve this one together? Yes, we can. Let's go for the first one. Yes, I know the chain rule now. D by dx for len 2x. This is exactly, I remember the chain rule all the time, like boxes inside each other, right? So what is the big box? Is the len. What is the small box? 2x, right? The big box is len and the smaller box is 2x. So first, I will use the chain rule to have the derivative d by dx for len 2x. Then I multiply by the derivative of the small box, which is 2x, right? Now, what is the derivative of len? He told me 1 over, sorry, 2x. And what is the derivative of 2x? 2. So I cancel this out. So I will end up with 1 over x. Okay. Catch it? Okay, this is number 1. What about number 2? Number 2, I would like to have d by dx for logarithm for base 2 for 3x plus 2. Again, I have a big box, which is logarithm of base 2, and a smaller box, which has 3x plus 2. So this one, exactly like d by dx for the big box, times the derivative of the smaller box. Okay. What is the derivative of logarithm? 1 over 3x, what in front of the logarithm. Remember, the base here is not len. This is log for base 2. So I have to multiply here by log for a for the base e, right? Sorry. So this is 2. Okay, this is exactly, if I just remind you, log a, len a, sorry. So this one is len a. Now I finish the big box. I'll go for the smaller box, which is 3, only 3, because the constant 2 has derivative 0. Okay, now I can write it down. This is will be 1 over len a. Okay, 3x plus 2, and you have 3 over here. So you can write it down like this. Okay, 3 over 3x plus 2 len. What is a here? A is 2, so len 2.
دكتور ما يبين الشارع عندنا.
This is a, yes, this is a derivative. Okay, so I differentiate the big box. Okay, which is logarithm. What is the derivative of logarithm for base 2? Is 1 over what in front of the logarithm, and in the denominator I multiply by the length of the base. Okay, and then I differentiate the smaller box, which is 3x plus 2. What is the derivative of 3x? Is 3. What is the derivative of 2? Is 0. So no need to write 0, 3 plus 0. Okay, now let's go for the last one. How to solve this one? Yes, you remember you have a multiplication rule in this one. So be very careful here. You would like to have d by dx for x ln 3x. So in this case, you remember the product rule. Okay, so what is the product rule? D by dx for f times j is f times j prime plus f prime times j. Okay, so let's go call this one f, call this one j, or the first and second, it's up to you. So this one will equal to the first one, you keep it as it is, and then you differentiate d by dx for the second one, plus the second one times the derivative of the first one. Okay, now what is the derivative of ln 3x? 1 over 3x times the smaller box, which is 3x has a derivative 3, plus ln 3x. dx by dx is 1. This is 1. Okay, so I can cancel out this one with this one, and this x with this x. I end up with 1 plus ln 3x. So in this case, I have two functions here, so I have to use the multiplication rule. Okay, and here is the solution. Okay, now let's go for the inverse function, which is the exponential function. How to find the derivative of the exponential function? If y equal to f of x, which is e to the x, so you can write x as ln x. This is the inverse function. I know what the derivative of ln y, which is 1 over y dy by dx. So I can find the derivative of the exponential function using the chain rule, right? So yes. So it is 1 over y. Okay. So yes, the derivative of the exponential function is the exponential function itself, unless you have coefficient for the power here, x. Okay. Now, if you don't have base e and you have any real number as a base a, so yes, you will have e to the x ln a, so you can divide this one into e to the ln a to the power x, and the ln will be cancelled with this one, so you end up with d by dx for a to the x is a to the x times ln to the a. Remember, when you differentiate the ln, you used to divide it by ln a. But when you differentiate a to the x, you multiply by ln a. This is the difference, because they are inverse functions. So in the derivative of ln logarithm to base a, you divide it by ln a. When you differentiate a to the power x, you multiply by ln a. Okay, let's go for this too. How to solve the first one? Yes, I have a multiplication rule. Very good. Yes. Now you remember for the first one, d by dx for x a to the x. This is the first derivative. Okay. Yes, I remember the multiplication rule. So this is the first one and this is the second one. So x times the derivative of the second one plus, yes, the second one times the derivative of the first one, sorry. Now, this is 1 because this is dx by dx. And I know the derivative of a to the x is what? Yes, a to the x multiplied by what? Ln a. Okay. Plus a to the x times 1. Okay. Now, I can leave it like this, or I can take a to the x as a common factor, and I will have x ln a plus 1. That's it. Okay. Let's go for the second one. I'm looking for the first derivative of y equal to 2 to the ln x. So I have d by dx as a first derivative ln x. This is using a chain rule. I know d by dx for a to the x is what? Yes, a to the x ln a. I know this one, right? So what is a in your case here? What is the base? A is 2. A is equal to 2. So d by dx for 2 to the ln x is equal to what? Yes, 2 to the ln x times ln 2. Did you finish? No, I didn't finish. This is multiply by what? Multiply by d by dx of the power. Okay? Because I have two boxes. The big box is 2 to the power. Okay? And the smaller box is the power itself, ln x. Okay? This is a chain rule. Multiply by the ln x. I know this is 1 over x. Okay? Now I would write it down. So this is up to the chain rule. It is 2 to the ln x times ln the base 2 multiply by the derivative of the power. So this is 2 to the ln x ln 2. What is the derivative of this one? 1 over x. So I can write it down as x is here, ln 2 is here, 2 to the ln x. Okay, this is the derivative of the second one. Yes, I know once you reach a rational function like this one, you remember you have a division rule, right? So now we memorize the last lecture. This is a division rule. You would like to have the first derivative. The first derivative is d by dx for what? Yes, e to the x plus e to the minus x, and this is e to the x minus e to the minus x. Okay? Yes, remember the division rule. Yeah, you have to remember the division rule. The division rule. What is the division rule? Yes, d by dx, if I have the numerator over denominator like this, yes, I squared the down one. I have it up without squaring times the derivative of the numerator minus the numerator times the derivative of the denominator. Okay, so I remember this one. Let's apply this one. So what I have here, the denominator is square, and I will have it here without the square. Okay, times the derivative d by dx for the numerator. I'm just applied step by step, just not to get confused. Okay, minus, yes, the numerator itself, e to the x minus e to the minus x times, sorry, the derivative of, yes, I will cancel out this one. The derivative of the numerator, e to the x plus e to the minus x. Okay. I just apply the division rule here. Let's have the derivative. So this is e to the x plus e to the minus x square, keep it. This is e to the x plus e to the minus x. Now, let's have the derivative for this one. What is the derivative of e to the x? It is e to the x minus, what is the derivative of e to the minus x? E to the minus x times minus 1. Okay? Minus e to the x minus e to the minus x. And what is the derivative of e to the x? E to the x. What is the derivative of e to the minus x? Minus e to the minus x. Okay. Now, look at this one. This is minus minus, so it will be plus, right? And this is the same as this one. So you have e to the x plus e to the minus x squared. Minus. Also this one, you have negative here and negative here. So this is the same bracket. So it will be e to the x minus e to the minus x squared over e to the x plus e to the minus x squared. If you would like to stop till here, that's fine. But this is exactly like 1 minus, yes, e to the x minus e to the minus x squared over e to the x plus e to the minus x squared. If you keep it like this, that's fine. If you would like, this is exactly like what? Like if I have 3 plus or minus 3 minus 5 over 3. You do it like that. 3 over 3 minus 5 over 3. So this one will give you 1. This is what I have done over here. Okay. Now we revise the multiplication rule and the division rule and the chain rule, right? Also, we solve this question. We left this question until now we can solve it because we know how to find the slope, okay, of the tangent, because the slope is the first derivative, and now we know how to differentiate ln x squared, okay? So exactly 1 over whatever in front of the ln multiplied by the derivative of what inside the ln, okay? So you have the dy by dx, and he's telling you this is parallel to the straight line y equal to x. So it has the same slope as this one. What is the slope of this one? Is 1. So dy by dx will equal to 1. From this one, I will get the value of x. And I substitute in the original function y equal to ln x squared to find y. I have a point now, and I know the slope is 1. I can find the tangent line using a point and the slope. Let's go for how to use a Matlab. If you didn't see the Matlab before, please go to the App Store, okay, and write the Matlab and download this software using your Gmail or your any email. You can download it and open it. It's asking you to register using email. So please go and download this one. I don't like to update now. Okay. How to solve this one using Matlab. How to differentiate or find this first derivative of y equal to ln to x. First of all, for any software, you have to define the variable. What is a variable? It is x and y. But if you write sims x, you define and you put semicolon just to stop him taken any action, right? And then you defined y. What is y? Y equal to, how to write no len in Matlab. It's not written len, it is written log. So he accepts log as len for base e. Okay, and open bracket to write as mathematically we write f of x, f open bracket x. So in any function in any software, we write the function f and open bracket, and then so this is log 2. Don't write 2x because in any software, in any language, you have to write the operation. What you are going to do with 2 and the x, you multiply them. So 2 star x. Now I defined x and defined y. Let's go for the action. What is the action? Is the command having the first derivative. What is the command having the first derivative? Is di double f def open bracket. I differentiate y. Okay. If you would like to differentiate y with respect first derivative, you write 1. Second derivative, you write 2. But if you leave it just def y, he will give you the first derivative. Okay. Yes. So the derivative of this one, as we solve it, it is exactly 1 over x. Okay. We solved this one, if you remember. Yeah, 1 over x. Yes. Okay. Let's go and do the second one. If you don't know how to do the first one, I will put you in the chat. I'll put you the command just to imitate the first one. Okay, so I put it for you in the chat. Let's do the second one. If I would like to have the derivative of the second one, let's go for that. Yes, here's the question. Okay. Now, I'll go for the last one just to have enough space. Also, I have to define the symbols or the independent variable, and then I define my function y equal to x star log 3x, so 3 star x, comma. Now I define x and y, semicolon. The action is first derivative, which is def for y. If you leave it like this, give you the first derivative. If you would like to have the second derivative, comma 2, third derivative, comma 3, etc. But I'm looking for the first derivative. Okay. Yes, this is the same answer as what you have here. Len 3x plus 1. Yes, len 3x plus 1. Okay. If you would like to not to have the same language, you would like to write it as a mathematics. There is a very nice command called pretty. Pretty for my answer. My answer is called ANS, so I act over ANS by the pretty command, and he will write it as a mathematics expression, right? Let's go for the last one we have done. This is the one I would like to do. Okay, we know how to write the logarithm. Let's go for how to write the exponential function. Okay. Now, again, I have to define the variable, independent variable, sims x, and comma, I will define my function y equal, yes, when you have a numerator with more than one piece, you have to open bracket. What is the exponential function? exp, open bracket. What is the power? X, that's fine. Close it. And next, minus another exponential function, exp, open bracket. What is the power? Minus x, so I'm writing minus x. And close the bracket for the numerator. And now I open another bracket for the denominator. This is the exponential function for x plus, exp for the exponential function of minus x. Now I finish the exponential function. I have to close the bracket for the denominator. Now, column, I will take the action by having the first derivative. What is the command? diff, open bracket, for what? For y. Sorry. Def y, if I'm looking for the first derivative. If I would like to write it in math mode, I'm just typing pretty. Command for ans, because this is the result, is called ans equal to this. So I would like to make pretty for this one, right? Now, yes, this is the last thing I have done for you. If you remember, 1 minus e to the x minus e to the minus x squared over this one, right? So I will give you this one, okay, in your chat. And now we'll stop until you download, all of you, download the Matlab and can share the screen and solve. This is my turn is over. Now you come to your turn.